Thank you for having me on the having me at the first CouchCon. Really appreciate it. I got maybe a little too ambitious because I was excited about the first CouchCon, so I have 9 things. We'll see if we can get through all 9 of them today. Let's get going. Okay. I thought I heard Christopher there in the background, but I'll keep going here. So these are the 9 things I want to cover. These are all things that are included in the Couchbase Server Community Edition, which is a totally free download, totally free to use in production. These are not the only 9 things you can do, but these are, I think, the 9 biggest things that I'm going to try to cover today. You're going to have a hard time finding another database that can do all these things by itself. And I'm still just talking about the free version. The enterprise version, which I promise I'll only spend 1 slide on later, actually even has more features than that. So just a little bit about myself here first. I'm Matthew Groves. I work for Couchbase as a developer advocate. If you have questions about this and I can't get your question, I'm monitoring the chat here the best I can. But you're welcome to contact me on Twitter. I also do a lot of live streaming on Twitch. Twice a week at least on Twitch, so you can always stop by there, ask a question. Those are very interactive. Lots of coding going on, questions, interaction, chat, all other kinds of fun stuff. So you can check that out there on Twitch TV/Matthew D. Groves. All right, so let's get on with it. So I have a few slides today. Some of the concepts I'm going to show you today are a little bit more sort of conceptual, and they're not something I can just show you with a code example. So I have slides for that, but I'm going to try to show you Couchbase in action as much as possible today. So the very first thing, this is kind of an easy one, right? It's store JSON data. That's not super exciting, right? A lot of databases can store JSON data, but it's a good place for us to start. So what I've got here is I've actually got just a console open here, and I'm going to just install Couchbase completely from scratch here. We're going to do it from the very beginning. So I'm going to do this in Docker. You don't have to use Docker to do this. I'm just going to type it here, but it just makes it easier to get started. I think if you like Docker, you can also just run it directly on Windows or Linux or Mac, whatever you want to do. So what I'm doing here is I am opening up starting a Docker image of Couchbase Server Community Edition, and I'm specifying some ports that I want it to open. I'm not going to use much of these ports today, but I just want to, for the record, I want to make sure that they're correct here in the stream. Couchbase, and I'm going to say community, and the latest version is 6.5.1. So I'm going to run this image. All this stuff's already downloaded, so we don't have to wait for that. It's just going to fire up a new image for me. But if you're doing this for the first time, you'll see some download dialogues here, because that's just the way Docker works. So now what's happened is I've just started a Couchbase image here on my machine in Docker Desktop. I'll switch over to my browser, and I'll go to localhost port 8091, which is one of the ports that we opened, and we get to the built-in Couchbase UI, and we're going to set up a new cluster here. I'm going to call it let's call it the CouchCon 2020 cluster. Very exciting. I'm going to put in a very insecure password of password, and there we go, and accept the terms, finish with defaults for now. We're not going to get into the nuts and bolts there. So here we go. Couchbase is up and running here on my machine. It's easy as that. Just one Docker command and a few clicks in the setup wizard, and away you go. Now, inside of Couchbase, you have these things called buckets. This is where you store data. I have no buckets yet, so I'm going to add one. I'm going to call it CouchCon. Why not? And I don't need to give it all the memory. We'll just give it a gig there. And we'll just use the defaults and hit add buckets. So there we go. Now I have a place to put data. It's not exactly a table. It's kind of closer to like a database catalog kind of thing. So if you're familiar with that concept, it's kind of a per application container, right? It's not something you would put every, you wouldn't have a bucket for each data type, for instance. So just as an example, I'll go to documents here. I'm going to add a document, just a little bit here. Here's the document key. It can be whatever I want it to be, 0001, for instance. doc001, and I put whatever JSON I want in there. So if I wanted to organize my data, what I might do is I might say, okay, this is kind of hard to read on the screen because of the small font. Let me zoom in a little bit here. I might say type, and this would be, I don't know, this will be invoice, for instance. And then I would have the invoice information here, like invoice number, 0001, something like that. So this is just a piece of JSON. Any valid JSON can go in here. It's just nothing special about type. It's just this is a nice way to organize your documents in JSON. Okay, so I'm already behind schedule, but I'm not going to actually add that because the next thing I want to show is that we can import data into Couchbase from CSV or from JSON files. JSON kind of makes sense because it's a JSON database. CSV I thought was kind of interesting to import that. So what I've got here is I've actually downloaded the Stack Overflow developer survey results from 2019. The 2020 results are not out yet, as far as I know. So I've got you can see a CSV file here from Stack Overflow. This is a big file. It's almost 200 meg. So what I'm going to do is, because I'm using Docker, I have to cheat a little bit here and copy this file into the Docker image. This is not something normally CB1 normally want to do, but it's going to make it easier, especially if you're following along at home. And then what I'm going to do is I'm going to actually, again, cheat a little bit here. I'm going to run bash,
I also
which is the
just
command line
literally
utility,
yesterday started a new podcast.
inside. Oh, it's not CB, it's CB1. Running inside the Docker image. So it'll give me a command prompt inside the Docker image. So you can see here, it's running on Linux. So I'm inside here. And now what I'm going to do is a command called cb imports right there. So cb import ships with Couchbase. This is a way to import data into Couchbase. So cb imports, and I'm going to import a CSV file into the cluster running on my local host here. So now I'm inside of the Docker image, so localhost works fine. Administrator is my username. Password is my password. The bucket name was CouchCon, I think. I'm going to generate a key for each one of these. Each row of CSV data will be inserted into a individual document. So I have to generate a key to go with those. So I'm going to call it survey : and you can give it a little sort of placeholder there. It's going to put in a GUID or UUID in place of that token. And then the file I want to import is file home so.csv. So this is going to start importing data. I think there's 88,000 total records in that survey data. It's going to start importing this into Couchbase. Okay, there we go. So all 88,000 are imported, no failures. You can do the same thing with JSON. I'm not going to show that example here, but it's cb import JSON. If I switch back over here to Couchbase, you can see my bucket now has 88,000 items in it. So there we go. We've imported data. I'll just show you it real quickly. This is not terribly interesting shape of data. Here's the survey, and here's the UUID that it generates, and this is all the data it's pulling from those CSV columns. So there we go. We just imported that data. We're ready to work with it. Okay, I think I'm back on track now. So the next thing I want to talk about briefly, this is something that's a little more conceptual, is that Couchbase has a cache, built-in cache, memory first layer of data that you don't have to do anything to get. You don't have to install something separate. You don't have to use a separate caching tool. It's built right into Couchbase. So it's just kind of hard to demonstrate because it's just there, it's working. But I want to kind of show you how Couchbase architecture kind of works at a conceptual level. The whole idea of what does memory first mean? Someone might worried, well, if that means if there's a restart, I lose all my data. Well, no, not exactly how it works. The memory there is to improve performance. It's to make data access faster, both reads and writes. So if we have a write coming in from an application, let's say, or like the import that I just ran, an individual write comes in. So we're inserting a new document, updating a piece of data. The first thing that happens is that data goes into RAM, and that's where it's stored. It stays there in RAM, all right? Now, there's also a disk. So we want to store our data to disk. In many situations, most situations, we want to keep it on disk just in case there is a restart that happens. We want to make sure that data is durable. So what Couchbase does is it does not wait for the data to be written to disk. What it's going to do is going to put the data into a queue, an asynchronous queue, which means that the data is going to be written to disk eventually. So access still goes through RAM, but it's going to eventually write it to disk. And it's usually pretty quick, depending on how many operations you've got going on. But that's the whole memory first concept there. Now, when I go and do a read, I'm going to read right from memory. So you don't have to worry about the data not being there when you do the read, because it's not going to go to the disk to get it. It's going to go to RAM to get that data. Now, the situation may occur where you may have more disk space than you have RAM, right? That's a common situation. So what happens when the RAM fills up? Well, if I go and try to do a read from the data and the data is not in RAM because it's been ejected from the cache, for instance, for some newer data that's in there, then we're going to have to go, and that's what's called a cache miss. Then we have to go and read it from the disk and put it into RAM. So it takes a little bit more time to do that read because we have to go and do some disk access to do it, but we're still going through memory first. We're always going through memory with Couchbase Server. So that caching layer is built right in. With other databases, you have to set up another tool to put that caching layer in front of the database, another integration or something like that. Okay, so that's it. Caching is there. It's built in. You get it for free with Couchbase. You didn't really see this very much, but this bucket here, you can see has 1 gig of RAM as the cache is 1 gig in size. 100% of the data is in cache right now. You can see 100% is resident. I don't have a ton of data in there right now, 88,000 records, and they all fit into RAM. So anytime I do access, it's going to get that data from RAM. Anytime I do an update, it's going to update it in RAM first. Okay? All right, that's three down. Next one, this is my favorite, possibly my favorite feature of Couchbase, and this is one of the things that is just something that people think is kind of unbelievable to people when they first hear this, is you can query the data with SQL. And now I say that's unbelievable because Couchbase is often considered to be a NoSQL database, which people take to mean, okay, well, I can't write my SQL queries. Well, that's definitely not the case. So over here in Couchbase, there's a query tab, and I can start writing queries up here, execute them, and get results. So if you've used a database like SQL Server or Oracle or something, this is kind of a familiar setup. You have a place where you type your query and where you get the result sets at the bottom of the screen there. Similar sort of thing with the Couchbase query workbench. So let's try writing a query. I'm going to do a select c.star. You should never do a star, but we're going to do that from CouchCon. And I'm going to call that C. That's where the C is coming from there. Execute this, and I get a failure. That's to be expected. Totally fine, because there is no index for that. So what would happen in a relational database, a normal database, is you could write this query and it would execute, but it's going to perform a full table scan. It's going to have to scan every single row in your database. So you should use indexes in relational too. It's just oftentimes we don't think about that until later when we actually have problems. And Couchbase is kind of getting ahead of that here and saying, hold up a second, make sure to put a good index in there first. Now I'm going to create an index. It's not going to be a good index, but I'm going to create one. This is called a primary index. What I'm basically doing is I'm enabling it to say, okay, it's okay to go ahead and scan every document for now. That's fine for development because we want to, sort of tinker with our query before we actually go and optimize it and tune it. So this is fine for development, not fine for production. Absolutely not. So just for demonstration purposes, I'm going to create that index on the CouchCon bucket. Okay, now that that index is done, let's run that query again. I'm going to limit it to 10 this time because I don't want to wait here all day for the results to come back. So give me everything from CouchCon, but the first 10 though. So execute that. Now I have 10 results here. And you notice the results are in JSON format, just like the data is in JSON format. So I should have 10 JSON documents here, right? That seems to be the case. So there's 10 of them. And I've got all the data here. So I did a c.star, all the data that it was imported from Stack Overflow. Probably don't want to do that. So let's just do something more realistic like a student. We're just going to select the student field. So this is a yes or no question that you answered on the Stack Overflow survey. Are you a student? Yes or no. The first 10 answers here are no's, yes, full-time, etc. There we go. So I can do the same kind of thing where I'm selecting individual fields. This is called a projection, where I just want certain fields from there. I can also get it in a table view. It's not returning the data in a table. It's still JSON, but I'm just viewing it in a table. Sometimes that's a helpful view. Okay, so there you go. That is just a really quick example of a quick SQL query you could run on Couchbase there. Now, you might also be wondering, well, can I do everything with SQL? And the answer is yes. You can do all kinds of stuff with SQL. This is not just, it doesn't just look like SQL. It is a full SQL with full capabilities. And one of those that people often ask about because it's a NoSQL database. Well, can you do a join? Because I got to have my joins. Well, we can talk about that later. You don't necessarily always have to have joins, but because we have SQL here, yes, you can do a join. So what I want to do is I'm going to bring in a different data set that's more conducive to joins. So some of these data samples ship with Couchbase. One of them is called travel sample. This is my favorite. Even though we can't do much traveling right now, we can still write data queries about it. So I brought in another bucket here called travel sample. It should have 32,000 documents here once it finishes loading. It's also going to automatically load some indexes for us, which is nice. So it's kind of already optimized a little bit. I'm going to show you a quick example here of a join, just to show you that it's possible. I assume if you've used SQL before, you know how joins work. But let's just say I want to select the source airport, the destination airport, and the airline ID. From my travel sample bucket, I'm going to call it R, because I want to just find the documents that are of type route. So I'm finding route. A route consists of one airport, another airport, an airline, and some information about that route, like how long the route is, what are the normal flights per day, things like that. I want to narrow this down even further. I'm going to say, just give me routes that start in Columbus Airport, CMH. That's my home airport. So that's the one I know the best. And again, just give me the first 10 of those. So execute that. And here's my results. So I have these results look like this. There's a destination. So there's a route from Columbus to Atlanta. And the airline is airline 321. Okay. Here's another one to Atlanta, airline 596. Well, if I'm building a travel website, it's not terribly helpful to show this to my customer, to the person viewing the website, because, well, what airline is that? So that airline name actually exists in a separate document. So that would make sense for us to do a join. We're going to join to the same bucket, travel sample. I'm going to call this A, though. We're going to join on the airline ID. And then this is a weird part here. I'm going to say meta a.id. This is just kind of Couchbase syntax to say the document key, the kind of like a primary key for a document. So I want to join that together where this airline ID matches the document key of an airline document. And then I'm going to bring in the name field from that as airline name. So execute this join. And so I've done a join here. You can see now that airline 2009 corresponds to Delta. All right. And this is kind of old data. So you can see AirTran in here is another one that flew from Columbus to Atlanta. So 1316 is AirTran. So there's a join. And yes, there's like a sort of a plan here, just like you would see in a normal relational database to show you what this query actually consists of, all the different steps, indexing and fetching. So if the query is slow, you need to optimize it. You can use this visualizer to see what are the slow parts of the query. Is it using the right index? What's taking so long, et cetera. So that's an important tool when you actually start to write queries. This is all included in the community version of Couchbase. Okay. Very good. So the next one is scale. Okay, this will be interesting to see if we can get through this in enough time. But one of the reasons that NoSQL databases, and Couchbase especially, is used by lots of our customers in the community is it is designed for scale, designed for horizontal scale. So we'll talk about what that means in a second. But I want to talk to you about some quick fundamentals. This is stuff that goes on behind the scenes with a Couchbase server, Couchbase cluster. As a developer, you don't really have to know and memorize this stuff, but it is helpful to kind of know how it works. So with that CouchCon bucket there, you can see the kind of the left side of the left side icon there. That's the CouchCon bucket. That's what we saw as users, as developers. We see this bucket. That bucket is actually made up of 1,024 what are called V buckets, which you might also be referred to as shards from time to time. Other databases call these things shards. In Couchbase, those shards are named V buckets. Each bucket has 1,024 V buckets that make it up. Okay, so when I'm putting data into Couchbase, I put a document into the CouchCon bucket. Okay, fine. But behind the scenes, there's an algorithm that Couchbase uses to say, okay, I'm going to put you in vbucket 0. The next document comes in, okay, I'm going to put you in vbucket 1, and so on. You're going to go in vbucket 2, and then the next one maybe goes in vbucket 0. And there's no particular order that these go in. It depends on how the algorithm defines it. But they all kind of get distributed amongst those 1,024 vbuckets. So behind the scenes, you have all these documents that are stored in all these vbuckets, and they all belong to the one CouchCon bucket. Okay? So what is the point of this? Why put into vbuckets? Why these shards? Why bother with this? Seems like extra work that I don't really even get to see. So with one node, one server, like I have running right now, yeah, that is the case. There's really not a lot of point to having it in those different vbuckets. But since this is a clustered database, a distributed database, I could add another server to the cluster. So what would happen then is I'd have now 2 nodes or 2 servers running in the cluster. And if I add that second server, then I can rebalance these buckets. I can say, okay, the first 512 are on node 1, and the second 512 are on node 2. So I can easily just take those 1,024 buckets and move them around amongst all the different servers. And again, this goes on behind the scenes. This is automatic. You don't have to know this as a developer. But what I've done here is I've doubled the capacity of my database, of my cluster. So now each server handles 50% of the reads and the writes. And I can keep doing this. I can add 2 more nodes. And now I can have 256 vbuckets on each one of those nodes. And again, this all goes on behind the scenes. There's still just one CouchCon bucket that a developer interacts with. But it's automatically scaling out, automatically sharding behind the scenes. And so for those of you who have worked with distributed databases in the past, I want to make one thing very clear here, because there's a big difference here between how Couchbase works and how many other databases do this, is that each one of these nodes, so I've got 4 servers, 4 nodes here, 4 different machines or VMs or whatever. Each one of them handles both reads and writes. It's not like a master-slave setup where like one node is in charge and the others are just kind of read-only backup replica copies. Every one of these nodes will handle reads and writes for those individual vbuckets. So if Couchbase says, okay, you go on vbucket 0, well, then you go to node 1. If you're on vbucket 300, okay, you're on node 2. And so that kind of distribution is managed by Couchbase. That routing is handled. It's built in. There's no need for a load balancer or anything like that. It's all handled by the server. Now, there is replication. I'm going to get to that next. But I want to, let's see if we have time here. I want to kind of show some scaling in action here. So I'm going to open another terminal window here. I'm going to run another instance of Couchbase. So this is going to be CB2, and this is also going to be Couchbase Community 6.5.1. So I've got 2. If I Docker PS, you'll see I've got 2 containers running Couchbase here. And so what I can do then is I can say, okay, Docker inspect CB2. All right. This is just going to give me some information about that one I just created. Let's go back to my browser here. So back here in the servers window, you can see I've just got the one server. I'm going to add a second server here. So I created that one. This is the IP address we found. I'll put in the password there. Add that server, and it'll take a second here to add it, but there we go. So add a second server, and if you notice up here, all the items are still on the first server. I'm going to go ahead and click the rebalance here. This will take a second to actually make that happen, but it's going to now move the data around, so it's on, half is on each server, basically. And this is happening behind the scenes. You don't have to take the cluster down to do this. This is all happening live. So it all stays up. It's all still available, even while these things happen. So that's just going to take a second to run, hopefully not too long. You can see in the background, things are starting to move around. There's a question I see in the chat here. How about join across nodes? Absolutely. So again, as a developer, you don't really have to worry about the details of all those different nodes. It's all handled by the Couchbase SDK and what's called the cluster manager that's built into every single node. So when you send a query to do a join, it's going to actually go through a query service that's out here. You can see the query service and index service. And it's going to use those to access the data wherever it is in the cluster. So a join has no effect on whether you have one node or 100. A join is going to work the same way from a developer's point of view. So there we go. The rebalance is done. It took a little bit longer than I expected, but now you can see I've got 2 nodes here and about half the data on each one of those servers. And that's it. So there we go. So now I've scaled up. I can keep doing this. I can add more and more nodes if I want to, and keep adding more capacity. Okay, went a little long there, but that's okay. I want to talk about replication next. So automatic replication, because the whole idea with the distributed database, a highly available database, is that I have multiple machines. So if one of them goes down, then we can still keep going. It's not like if I have a single SQL server, a single MySQL database, if that goes down, my whole application goes down. With the distributed database, availability, high availability is one of the things we want. So how does Couchbase do that? So there's a concept called replica vBuckets. And so I want you to imagine that these 3 red buckets here represent the collection of vBuckets we talked about. So the first node has 340 vBuckets. The second one has 340. I think the math is off there a little bit because doesn't divide evenly, or maybe it does. I don't know. But anyway, that's those are the vBuckets there. If I turn on replication, which is very easy to do in Couchbase, by the way, I can show you here in a second how to do that, then I want backup copies of the data in these vBuckets. So if I have 0 through 340 on node 1, then what I want backup copies of those vBuckets on nodes 2 and 3. That way, if node 1 just catches on fire or disk drive fails or something happens there, then those backup copies on node 2 and 3 can just be used to keep going. They'll be promoted out of replicas into active vBuckets and will be on your way. Same thing with node 2, 341 to 682, copies on nodes 2 or nodes 1 and 3. And then you can see the same thing with node 3, copies on node 1 and 2. That's with replication set to 2. And the way this works is, I mean, it's more complicated than what I can explain in 10 seconds here, but there's a protocol called DCP, Data Change Protocol. This is kind of a bus that Couchbase uses to communicate data changes across the node, across the cluster, and even sometimes outside the cluster, which I'm going to talk about here, although we are running short on time, I think. It's still interesting, so we'll talk about it here. So this may be a little confusing here. That's okay if it's not a big deal. Just want to cover this in a short amount of time. So I want you to imagine we have a node of Couchbase, and we talked about the memory first already. So a write comes in to RAM, and then it eventually gets saved to disk. Fine. That's with one node. What if I have 2 nodes? Well, how's that replica going to get saved? So when the write comes into RAM, it also goes into a queue to be transported over to other nodes so that those nodes can save it to a replica. Okay, and so those are all in the same cluster. Now, suppose I have 2 different data centers, like the West Coast and the East Coast. I have another cluster, which I've just made a small box to convey that. I don't want to put all the graphics in there, but it's another cluster of Couchbase. Let's say it's running on the East Coast, and this one on the left is running on the West Coast. Well, if I want to have my data close to my customers, geographically speaking, then I can use a Couchbase replication feature called XDCR, Cross Data Center Replication. And so the data, when it comes into a write, it will also be queued up to be replicated across to a different data center using XDCR. And it can go both ways. It can be a master-master system, it can be a disaster recovery, it can be a backup cluster, whatever you want to use it for. The replication is there between clusters as well. Question came in the chat, is replication only for fault tolerance or performance gain? I don't see how it would give you performance gain per se. You can, just to go back to this slide, if you wanted to, you can actually make a request to say, give me a backup copy of the data. Give me one of the replicas. So, I mean, I don't know if that's going to give you performance gain, but it's certainly possible. But it's mostly, yeah, for fault tolerance, I think, for high availability. is the idea there. So if one node goes down, the other nodes can recover gracefully with no downtime. That's the whole point of that. But the XDCR performance game there might be if your customer is isn't closer to a data center in the East Coast. If that's the reason you're doing it, then that could be a performance gain from your customer's perspective. Absolutely. Yes. Okay. Let me just see. Actually, I'm going a little ahead of schedule. I'm talking too fast. You slow down. That's okay. We're doing fine. Thank you for the questions. Keep them coming. Okay, so that is replication. That also comes in the community edition. The next one I want to talk about is full text search. So this is a pretty cool feature of Couchbase. So if you want to do a query, you want to query your data with Nickel. This is called Nickel, by the way. This is Couchbase's version. If I wanted to say and source airport like, CMH, that's a kind of text search, like a wildcard match. So that's useful in some situations. But if I'm trying to search for keywords, or I'm trying to do a language-aware search, this is going to get really unwieldy really quickly. So the alternative to that is a text-based search, kind of like when you do a keyword search on Google. It'll search for text content of words that are close to that, and it'll rank them by this is the one we think is most relevant to you based on the search criteria you use. Now, in reality, Google uses a lot of other criteria, not just the text, but that's kind of the basic idea. If you want to add a text search to your website, if you're creating an e-commerce site with a catalog and you want people, if I'm searching for sock or socks, I want to get results that have the word sock in them, or socks, or the ones that say sock more times than not are more relevant, that sort of thing. So we can do that with Couchbase with what's called a full text search. So I'm going to create a full text search index here. I'm going to add this index. I'm going to give it a name. Let's just call it IT FTS for full text search. Sorry, IX for index, FTS for full text search, and we're going to call it landmark because I'm going to search some landmark data in our travel sample. So travel sample has some documents where type equals landmark. So I want to leave this here as type as a way to identify them. If I use something different, maybe you like to use the doc type name instead. Or maybe if you're using Java Spring, you say _class, something like that. I'm going to keep it as type for this. Okay, and then I'm going to uncheck the default one. The default one is a fun thing to play with. It'll basically index everything. That's a bit much, so we're going to uncheck that. We're going to have new type mapping in here. I only want to index documents where type equals landmark. That's what I'm saying here. And then I'm going to say OK. And then I only want to map the content field of landmark. So not every piece of data in a landmark document is useful for a search. So I'm only going to search for content. Okay. Wait, I think I did the wrong thing. I wanted to add child field. Yes, sorry, field, content. So content there. I want to check this store button as well, and you're going to see why in a second here. You don't have to, but I'm going to go ahead and check that store. Everything else I'm going to leave as default, and let's create that index. So it's starting to create. Keep an eye on this number right here. That was mighty fast. Now it just indexed the data that we already had in our travel sample bucket. And as new data comes in, it's going to automatically update the index here in the full text index as well. Now, when I was preparing for this, I must have been hungry because I'm looking at my notes here, and I want to start with a search for breakfast. So we're going to do a quick search. This is in the Couchbase UI. Of course, the full text search can be performed from SDK of your choice in your .NET or Java or Node application or what have you. But I'm just showing it here in the UI because it's just more convenient for me to do that. Here are the results. And you can see that, okay, landmark 25459 has breakfast in there, and it highlights it. Because I checked that store, but the store checkbox, it's going to store the actual contents in here and highlight for us. And down here, you can see another one has breakfast in there twice. You can see the ones that have multiple breakfasts seem to be more relevant. And down here, it only has one breakfast, so not as relevant. Well, this one, so maybe there's more to it than that. But we can also just click this if you want to. If you really want to nerd out and go into the whole way it's calculated, you can show the scoring, and you can see how it's actually scoring these results. This is using a open source a text search engine called Bleve. That's B-L-E-V-E. B-L-E-V-E. Looks like that. You can go find that on GitHub. But Couchbase has it built into Couchbase Server as well. So once again, you don't have to set up a separate piece of software to do this. It's just all performing a search right on the data that exists in your database. You don't have to set up an ETL or a synchronization process and a separate server. It's just all built right in. You have to create an index. That's about it. Let's get a little crazier with the searches just to demonstrate. I'm going to say breakfast and give me a fuzzy factor of 1. You don't have to memorize this syntax. You probably won't ever use this, except for a demonstration in the UI like I'm doing. But we'll do a search for breakfast, fuzzy factor of 1. Notice now it picked up breakfasts, plural. So we've got language awareness. I think this is also known as stemming if you're into the whole text search thing. But there you go. We're picking up more general hits there on the term breakfast. Now let's search for breakfast burrito. Okay, so it's not searching for this exact string. It's just searching for documents that have breakfast and burrito in them. You can see here it found one as breakfast here and shrimp burrito there. And here's one that just has burrito, but it's in there twice, and so on. So it's giving us some results there. Let's just say I want to force burrito to be in the results. So I'm going to say plus. I must have burrito. I want to, kind of prefer results that have breakfast in them. So I do a quick search for this. Oh, it looks like it's the same results. That's not really what I want to demonstrate, but you kind of get the idea. It's this kind of query syntax here. And if you go to this documentation, you'll see more about that there. So this isn't a super complicated text search right here, but for many applications, that is going to be enough for a catalog search, for instance, or if you're looking for, if you're running medium.com or you're running dev.to, you have a search engine up there on the top of the screen. You could have this built into your website or your e-commerce catalog and so on. And I just want to emphasize that there's no ETL. All I had to do was set up this index here in the search tab, and there's no extra software to manage. It's all built into Couchbase. Let's go ahead and show you that this is working in real time. So if I go in here to travel sample, I'm going to add a new document. I'm going to call this doc1. And I'm going to put in my own document that says, okay, it's type of landmark. And the content is Matt Groves is not a fan of breakfast burritos, which is true. So I'll save this. So I just saved a new document. I didn't do anything else here. Let's go back to my, search index. Go to this one. I'm going to type in plus breakfast plus burrito with fuzziness factor of 1. And what's the first result? Doc1. Matt Groves is not a fan of burritos. So all that synchronization, all the index updating happened just built right into the software. No separate install required. Okay, that was number 8. Full text search. The last one I want to cover, which I'm doing great on time, so I'm really happy with this. Sync data with mobile devices automatically. So maybe you're sensing a theme here is that Couchbase and syncing data it's just really good at syncing data. From wherever data is, it can sync very easily. So I don't really have a full demo of this because I'm not much of a mobile developer, but it is a very cool feature. So you have Couchbase Server, which is this thing on the right that I've been showing off all of today. You can also have something called Couchbase Lite, which is an embedded database that can go inside of an iOS app or an Android app or something like that. And you can store data in there just by itself. And if you want to, you can use another tool called Sync Gateway, which will then bridge the gap between the databases that are distributed all amongst the different mobile devices, your mobile apps, and the database in your data center. And this is an offline first approach. So if you don't have an internet connection, let's say you're in a remote area or something else, you're in an airplane, for instance, you can still read and write data to the device. It's still going to work, reads and writes. And then when you get back into someplace with service, the syncing will take over and it'll sync those writes automatically to your data center in the cloud. And all that happens behind the scenes. You don't have to set up any sort of extra syncing code or do your own polling and create your own APIs and stuff like that. It all happens just based on reads and writes to Couchbase, and then you telling it, okay, go look to the sync gateway to start syncing data up. Easy as that. All right. So those are the 9 things. We got through them. We got through all 9 things. I'm excited about that. Very cool. I promised some bonus trivia because this is CouchCon. This is a brand new session I created just for CouchCon, by the way, because CouchCon, Couchbase, couches, it just makes sense. And so I thought I would throw in some bonus trivia because this is something I get asked about constantly. Wherever I go, representing Couchbase, people say, oh, is Couchbase just the enterprise version of CouchDB? Or they assume that I'm with CouchDB and not with Couchbase. So it's a common mistake, and I thought I would try to help correct this mistake a little bit and give a little bonus trivia in the process. So CouchDB is an open source project, still exists. It's in the Apache Foundation. There used to be a company called CouchOne. And by the way, this is a simple version. There are more details, but this is a simple version of it. CouchOne was a startup that provided support and services, things like that, for CouchDB. At the same time, there's an open source project called Memcached, or Memcached, however you want to say it. And there was an open source there's a startup called Membase, which provided support for Memcached, and they were working on a new product called Membase, which is a memory-first database. And so they decided at some point to merge. So they became one company. They took the couch from CouchOne and the base from Membase and started a company called Couchbase Incorporated. And they started a new piece of software called Couchbase Server, which you could basically think as a combination of CouchDB and Memcache in one piece of software, hence the memory first, but still storing to disk architecture. Now that was a long, long time ago. That was like version 1. We're on version 6.5 now. And so Couchbase's API really has more in common with Memcache than it does with CouchDB. It's just that the name is kind of similar. So CouchDB still exists. I think they're on version 4 now. They're still chugging along, but it's not the same API. It's not the same feature set. All they really share is that they have Couch in the name. And there's a few bits, like some old bits of CouchDB in deep within Couchbase Server source code, but less and less all the time. And it's like a heavily forked, modified version of it. And Memcache still exists as an open source project as well. Couchbase Incorporated does not provide support for CouchDB or Memcache. So there you go. That's the history of why Couchbase is called Couchbase. Okay, I promised I would only spend one slide talking about the paid version of Couchbase. This is Couchbase Enterprise Server. So 2 main differences. One is that it has more features. Some of them are eventing. So if you want to write some JavaScript code, like in a serverless way, to respond to data changing or data being deleted, things like that, you can write some events. You can use analytics, which again is kind of a no ETL way to do some BI, massive parallel processing, complex queries, again with SQL against Couchbase data. Multidimensional scaling, which is more about tweaking. I showed you kind of a simple version of scaling today. Multidimensional allows you to do some more tweaks and adjustments around the services you want to run. And there's lots more. If you want to go learn more about that, you can go to that website there. It's got a big, long breakdown of the differences between Couchbase Community and Enterprise. The second thing is support. Couchbase Incorporated sells support for Couchbase Server Enterprise. So if you are in a large enterprise and you want to be able to file tickets against an official support organization, Couchbase offers that for the enterprise version. Next steps for you. These are all the different things you can do next, and you can do just one of these if you want to. You can do all 6 of them if you want to. You can download Couchbase. I just did it with Docker today, but you can certainly just run it directly on Windows, Mac, or Linux. You can get it in the cloud marketplace. You can have a Kubernetes operator to run it. There's very soon, going to be a completely managed cloud offering called Couchbase Cloud. That's in like a beta right now. That's a full DBaaS offering that's coming very soon. If you want to learn more, want to interact with me, ask questions, we can do some demos, interactive stuff. You can find me on Twitch. I mentioned this early on, but Twitch/Matthew D. Groves. Pluralsight, if you have a Pluralsight subscription or you're thinking about getting one, you should definitely check out Pluralsight. They have lots of courses about Couchbase, about Nickel, Couchbase Lite monitoring. I'm going to have some of my own, at least one of my own courses on there soon as well. You can contact me. That's my Twitter, my email address. I'm happy to jump on a video chat with you, do one-on-one, answer questions, help with Couchbase stuff, whatever. If you have tech questions, you can go check out Couchbase forums and the developer homepage. This is kind of a new project we've been working on. It's a great place to start if you're a developer. You can kind of skip all the marketing stuff and the stock photos and stuff and get right down to business with the developer homepage. The question came in, Elasticsearch seems to have many of the same features, but no join, no SQL. That's correct. Does Couchbase have facets for search? Yes. Yes, it does. I'm not a full-text search expert, but I have done some facet stuff. It's been a while, but yes, you can do it with Couchbase's full-text search built in. Absolutely. Okay, that's it. So thank you very much for coming to CouchCon. I really appreciate it. Thank you for inviting me on. Thank you for all the CouchCon volunteers and all the great questions in chat. We have maybe a couple more minutes. If someone else has a question they want to throw in the chat there, happy to do that. And I will also be in the Slack, if anyone's in the Slack, hanging out there for a while. If you have questions, want to follow up, happy to do that.